Let's take a look at problem number 3. f of x equals 1/2 x squared plus 2x plus 3. Repeating the same procedures that we did before, we'll first find the vertex, and then we'll find 4 more points to graph our function. So to find the vertex, x equals negative b over 2a, or we could call it h. Vertex is hk. In our problem, a is 1/2, b is 2, c is 3. So negative b over 2a, b is 2, a is 1/2. 2 times 1/2 will give me 1 on the bottom, 1 in the denominator, so I have negative 2 for my x-coordinate. Negative 2 for the vertex, so k will be f of negative 2. Plugging that in, 1/2 x squared plus 2x plus 3. And we'll put in a negative 2 here. Negative 2 squared is 4. 2 times negative 2 is negative 4. 1/2 times 4, 2, minus 4, plus 3. I have 5 minus 4, which is 1. So my vertex is negative 2, 1. Choosing points on either side of this x-coordinate, since my a is 1/2, I want to choose values for x so that when I multiply x squared times 1/2, I'm not left with a fraction. What I mean by that is, I don't want to choose negative 1 here next to the negative 2, because when I plug in negative 1 and square it, I get 1, and then multiply by 1/2, I get 1/2. So I have to carry around this fraction. We get to choose whatever we want to for values for x. So why not choose values for x that will let me have whole numbers to work with? We know how much we love working with whole numbers and like to avoid those fractions as much as possible. So let's avoid the fractions. Let's let x be 0 and 2 on the right of the vertex, and then we'll go by 2's, negative 4, negative 6. And just like before, since I'm keeping this pattern, notice 0 is 2 away from negative 2, and negative 4 is 2 away from negative 2, so I have the same spacing, the same difference between my numbers. Similarly with 2 and negative 6, they are both 4 away from negative 2. This will allow me to have that symmetry, just like in the previous examples. So we can plug in 0, and we plug in 0, we're left with 3. That also means that if I plug in negative 4, I'm going to get 3. Try it out, make sure that it works, and we can plug in 2, 1/2 times 2 squared plus 2 times 2 plus 3. We get 1/2. 1/2 times 4 is 2. 2 plus 4 is 6. 6 plus 3 is 9. And now all of these numbers are positive. When I draw my axes, I want my x-axis to be low. Let's see, I go out to negative 6, so maybe I want to make my y-axis a little closer to the right side. And then these can all be by 1s again. Plotting our points, negative 2, 1, 0, 3, negative 4, 3, 2, 9, and negative 6, 9. And we end up with a parabola that's wider than our previous parabolas. It's a little wider, and that's exactly what the a value does. The a, if it's less than 1, makes the parabola wider. It's not going to climb as quickly upward. Noticing on the graph, it does not cross the x-axis at all, so we have no x-intercepts. We don't know how to solve this type of equation just yet. It is not easily factorable, so we would not be able to factor it and try to solve for x. But from previous examples, particularly in the first part of this lesson where we had each of the 3 different types of solutions for a quadratic equation, the solutions to this equation are complex numbers. Since my parabola does not cross the x-axis, my solutions are complex. there's no x-intercept for this graph, so I have complex solutions. Interestingly, complex solutions come in pairs. We'll learn more about why that is when we get into solving the equations using the different methods that we have.